All right. Um, so it's 12 o'clock now, so I'm just going to kind of test to make sure I can hear myself. Um, all right. Cool. Cool. All right. So thank you everyone who's joining today for today's webinar. Today, we're going to be kind of going over a topic, just data analytics for small and medium businesses. So this is really focused at businesses that are probably somewhere in that 500K to several, maybe eight-figure kind of range. Kind of just more focusing on people who maybe have been limited before by maybe just access to technology, access to knowledge, access to people who might have that, and figuring out what you can do with all the new data that's kind of coming around, all the new technology is coming around. So a lot of this talk is going to be pretty focused at covering a lot of vocabulary and concepts, and a few use cases of what I've done in the past to kind of help out some other companies to kind of utilize their data in ways for them to either save money, find problems, things of that nature. So just a quick background on me. My name is Ben. I've worked in the data field for now going around the range of like 7 years, everywhere with kind of the data engineering programming background. And I've worked in healthcare, for startups, transportation, big tech, pretty much the gambit. And I've pretty much worked with most data at this point. I also kind of manage Medium as the Seattle data guy. So I write a lot on the topic, everything from how to do data analysis to how to manage kind of things like data warehouses, streaming data, batch streaming, um, ETL pipelines, which are just a lot of fancy data terms, but basically just figuring out the whole what I'd call the data pipeline. So getting data from your data storage all the way to actually doing analytics, data science, building models, things of that nature. Also, let me know if I don't know if you guys can give Q&A, but let me know if you can't hear me. I'm gonna check if there's, but I don't see anything. So yeah, so I pretty much worked throughout that whole pipeline throughout my background. I've helped build several products for startups that are currently successful in the sense that they're profitable. They're not. I don't think for some of the startups I've built, I don't think they'll ever be public, but they're definitely things that are profitable, make the companies money, and are sustainable. So I built a lot of products in that realm with like data, things like healthcare fraud detection products. There's a lot with opioid during kind of the opioid crisis, and also a lot in transportation for building uh, im- basically improve transportation habits for companies. So helping one company that basically goes around and helps manage other companies' transportation so they can reduce the amount of like single drivers that are on the road, especially here in Seattle. If you're in Seattle, being able to reduce the number of single drivers and use alternative methods of transportation is a huge plus for multiple reasons, not just obviously environmental, but also our crowded highways. So there's that. So I've pretty much worked the gambit. So just kind of what's on the exam or on the agenda for today. First, I'm going to start out with just kind of a few examples of just using data in the past, what I've done. Really, they're really pretty straightforward, and I think that's why I like using them in the sense that like they're not something that you need, a huge data science background to do. You could do it. Just built these charts really quickly in Google Sheets, but they kind of show a quick story, I think, for multiple kind of use cases. So I like that because then pretty much anyone who decides to do it could do it. So that's why I picked those options. And then from there, we're just going to kind of go over concepts kind of throughout that data pipeline that I was talking about, which is data sourcing. So where do you get your data? 'Cause that's kind of the first step I'll always take when I work with any organization is where's the data coming from? What data do you have access to? Do you need access to other data? Data management and storage. So that's kind of a huge key factor, especially if you're in the BI data engineering space. Regardless of the size company you work for, whether it's a 500K, you know 10 million, $5 billion company, how you store your data is kind of important for analysis, because the whole point is making it easy to access, making it accessible to people. That's really what's held most companies back, is the lack of access to data. Usually data's there somewhere. It's just not accessible because either you don't have the talent to access it. If it does exist, you just don't have the systems to pull it out correctly. So data storage is kind of this big portion of it. Data processing, so how you actually get to manage all that data and get it to a point that it's usable. And then data visualization, but I'm kind of aggregating a lot of concepts in data visualization, because there's a lot that can go into data visualization. That's where you have things like metrics, KPIs, which is just a business term for key performance indicators, which at the end of the day are usually just some sort of ratios or something of that nature, percentages, that just say how your business is doing. And you usually have a few of them that kind of each other, just so that you're kind of balanced. So the data visualization is going to be kind of talking about some tools you can use, but also kind of talking about some concepts in the whole field of data. And then I'll have like a quick Tableau demo just to kind of show that it's really easy to use, for better or for worse. I think the ease of use is both good and bad, and I'll kind of talk about it then. But I'll just kind of show like, hey, this is Tableau. You could also use a varying array of other tools, and we'll kind of talk about that as we go on. So just to give you some quick examples of what I've kind of done in the past. So just before I go into the picture, so basically what we're talking about is like, one is kind of tracking overuse in healthcare, but also you can use this. The other kind of example I've used this before is kind of also finding power users. So they both kind of are going to have similar concepts. Also calculating savings and future profits. And so that's just a method of trying to figure out how much like an individual person basically could be saving you or costing you based off of an event. And so we'll kind of look at that in a chart so that it simplifies it. So first, let's go over kind of tracking overuse in healthcare. So tracking overuse in healthcare and kind of spotting power users, it's actually pretty common to find these kind of things where I use the example of opioids. So I don't know, for those of you who maybe pay attention to the whole opioid crisis, but basically one of the crazy things that happened was they were basically finding out that like there was this one city in middle America that was getting somewhere upwards of like 30 pills per day per person in that town. And just doing that simple math, you would have figured out that doesn't even sound right. And so doing a simple ratio like that is one very easy way, like in overuse cases, that we kind of spot outliers very quickly and spot things that don't make sense, because they actually happen a lot. It's pretty common that you'll have this case. Again, another term is power users, but you might have that more with like product and digital products. So I do that also with digital products. But you kind of have that same case, in the healthcare, where you will have people or providers, specifically like healthcare providers, who might do a certain procedure that a lot more than others, especially like emergency procedure. And this may or may not make sense. Like maybe a normal doctor for some reason is billing for tons of emergency procedures. That's usually some sort of red flag. And so you can usually spot that pretty quickly. So if you, for example, look at some of these charts below, the one on the left, basically, this is pills, but you can look at the pills, basically pills per person per day. It's just an example versus like the total cities. So most cities will probably be whatever in this range. This is obviously still kind of high, but it's just an example. They'd be in this kind of safe, healthy-ish range where it's like, okay, only one person or one pill per person per day. And they'll always be kind of this general, because most people are average. But there are always going to kind of be, some cities that might be weird. Again, or it could be cities, it could be providers. And here you can see them denoted by being on the right side, but you can also use a kind of a scatter plot. Again, these aren't complex. You could plot this pretty easily. Or I'm just plotting, people versus pills. Where there's this kind of standard trend here, where it's like, okay, it's pretty close to one per person. There's clearly some outliers, and they are the exact same outliers here. And so that's just one of those things where you can quickly see, oh, there's a problem here, and here are the exact spots or cities that I need to look into, or providers or storefronts it can kind of use you can kind of use that pretty broadly. Or again, power users. It's the same thing with, like, when I say power users. Maybe you've got a digital product and you want to figure out who are the people that are using certain features the most. Well, then you might be interested in looking like how often a person logs in over feature usage or something like that. It's a pretty, it's two metrics, two counts, and then you just kind of put them against each other. You can either turn that into a ratio, you can turn that into, again, just a scatter plot, but it's just a really quick way to visualize something and see the problem. Or again, it could be a good thing in the sense of like power users, but it lets you quickly see where those things exist. And so I've used that, for instance, a lot in healthcare overuse. And basically when I built that product or helped build that product, within 6 months of building that product, they basically, and then essentially paying us for it, they basically came back and said they've already, pretty much gotten 75% of their ROI, and that was 6 months after, just by being able to say, oh, these are the healthcare providers, these on the right that we need to look into, and they went into there and worked out the problems that they were having and moved them back over to where most of the normal people were. And by doing that, they helped reduce their costs. And so doing things like that quickly is honestly what typically needs to happen. I think a lot of people think you need to do complex analytics. Oftentimes, it's pretty simple things. You just need to know where to look. So similarly, I think, and this kind of ties into even into overuse and being able to track future savings and profits or things like that. Another thing that we've kind of done is looked at kind of the cost, increased cost due to like a chronic disease, like it could be diabetes, whatever it could be. So unlike your typical chart where when you think about time, where you might think about time more in the sense of a month or like January 12th. One way you can kind of look at time, especially when you're looking at healthcare, is the first month essentially someone experienced some sort of disease. Like let's say the first month they were diagnosed with diabetes, and then from then on is the future. So in this case, 0 is that first month, where they had their first case of, again, let's say diabetes, as it's a chronic disease, and from then on out, you could just say the chronic disease expenses are whatever. You can just have that as a flag, right? Like as in medical care or healthcare, we have basically certain codes, HIPAA based codes, that you can, or procedure codes that you can basically call out, and they might reference something like diabetes or something that is connected with that chronic disease. And so you could theoretically say that if you were to pull out that information in any of those cases where it was driven by that chronic disease, that expense wouldn't have existed, and then you kind of know how much money you could save in the future if you could reduce the amount of cases that were occurring. And again, with chronic diseases, some of them are not necessarily treatable, but they might be avoidable with the correct measures put into place. And so that's one of the things that when you're trying to find where you can put your resources, this is one thing that you'll often do is like, well, where's the biggest problem? Maybe for one chronic disease, the savings isn't as much, and another chronic disease, there's huge amounts of savings. Especially as healthcare becomes more expensive, people are trying to look into this and figure out where can they preemptively get to people, because how can we end up reducing our costs. But it's very similar even with like calculating future profits, in the sense that maybe this 0 month instead is referencing the first time a person was exposed to an ad or something like that. And so there's a couple of ways you can kind of do this, and it can really just show basically the magnitude really quickly. In this case, the red is kind of the magnitude of either the savings or profits if you were to do some sort of or improve some sort of program that either, again, helps reduce some sort of chronic disease or helps expose people to your product or something of that nature. And it's just those things. I think, again, this chart isn't complex. It's really just calling out when someone was first exposing and what has that exposure done since then. And you can essentially think of this as the average total spend. I shouldn't put total spend. It's more of like the average total spend per person. And so again, these two charts aren't very complex. Like 3 charts aren't very complex, but I think they quickly point out problems and also possibilities without having to be super, data sciencey. And I think those things that kind of get missed, and they help really guide you on eventually what you can do in data science. And that's kind of where I'm going to kind of talk through for the rest of the talk. Is it kind of starts with data sourcing and goes from there. This is kind of just the baseline analytics, and then from there you can build. Okay, so where do we start our data journey? So whenever I kind of go to clients, some of the questions I typically ask is, well, one, what questions are you trying to answer? When they come to me and they might dashboard, generally try to are you trying to answer, and then what decisions are you trying to make based off of those questions, essentially. Because some people just want kind of a report out that says, hey, how many cars am I selling or something, or am I increasing or decreasing some sort of sales, and they might not do anything on that question or answer that they're provided. And so generally I try to find opportunities where I'm working with someone where I can actually help them make decisions. Like, if they see, for instance, that a company is doing poorly in some sort of transportation aspect because they're doing a lot of single use drivers, well, how can we improve that is usually the question. Then you want to drill farther into the data and figure out who's single driving, and is there ways we can improve, change those patterns within those people. So that's usually like where I start with part of the data journey. Is like, what are they even trying to answer? Because if I don't know what they're trying to answer and what decisions they're trying to make, I won't know what type of data to look for when we do data sourcing. Another question I usually like to think about is, are you looking more for operational or analytical data, or like data for that operational tends to be more tracking currently happening, in the sense, you just want to know how many miles are being driven, or how many cars are on the road. It's something that's a little more just operational, really doing an analysis into why. It's just doing, give me the current stats of now, which are kind of two different aspects. One just kind of tells you where things are, kind of looking probably in the past a little bit and trying to figure out why those things are the way they are. And those are kind of two different things. And generally, when you build things like dashboards, you want those to kind of be separate, because you don't want people to get confused in what decisions they're trying to make or what they're trying to work on. And then most importantly, do you have data? I've definitely gone with clients that, I've talked to them for a bit and realized that they didn't even have any access to any data that would be worthwhile. Else, like just email addresses, or emails, and that might be sufficient enough to actually build some sort of either product or insights that might. So definitely always a quick question I'll ask is, what data do you have access to? And so that kind of brings us into the next slide. So wait, yeah, sorry. That kind of brings us into the next slide, which is starting to figure out what data you have access to. And so data today is much easier to access. In the case of places or companies like Salesforce or Workday, also pretty much any sort of internal transaction system or other systems, generally there'll be sort of API or access to a database, or reports that you can get pretty easily in these systems, that make it much easier to have data. I've definitely worked again in healthcare where some of their systems are still kind of old, and even getting things from our ERP, which is just your enterprise kind of management system, is very difficult, because they were built a long time ago. There are limitations for various reasons. They didn't necessarily think about connecting together back then, or they wanted to keep control. Those companies want to keep control of that data, and they didn't necessarily want companies to access that data. That changed, I think, since companies like Salesforce and Workday have come around, where they really have opened up APIs and things like that, because they've made such useful products that they don't really care if you pull out their data as much. And so you want to start figuring out, well, what data do you have access to? Again, Salesforce and Workday are easy points, but there are other basically CRMs, which are customer relationship management systems that you can have besides Salesforce that probably still allow you to pull data. Workday, again, internal transaction systems. Basically, most companies have some sort of transactions that they're doing. It might be buying things, it might be driving people places. Healthcare has its own, again, something like that, where you're just doing those transactions and seeing how people interact with your company on a day-to-day basis. So that's what I basically mean when I say internal transaction systems. And usually that requires data to be stored somewhere. Okay, but now what do you do with all of this? Is kind of the next question. And so now the next step is storing and managing your data. And for a very long time, even now, like the way most people store data is in what we call a data warehouse for analytical purposes. So they might be pulling out all this data from all these different systems and kind of storing it in the centralized system. And there's various arguments, the actual technicalities and nuances of what a data warehouse is. There's like data marts, there's data lakes, different aspects. But at the end of the day, it's about creating some sort of data storage system. Some people now are going to platforms where an analyst can come to and pull out data really easily that connects all this data together. And that's kind of the thing that usually is missing, is like, maybe your internal transaction system has the operational side, but none of the finance data. So you can't actually connect, how much whatever it might be, maybe one ride or one customer is costing you or making you, because you don't have those systems connected. And so being able to connect those systems is where getting and going is. You want to connect your Workday data with your Twitter data, with your, all of that data into one central repository. Because from this, after you've kind of built that, then it's much easier for your end users, your analysts, whoever it might be that wants to use this data to really work with it. Otherwise, it's all typically stored kind of in these databases that aren't easy to access. That's the big thing. It's generally, especially with like third-party systems or like even with sales, an analyst will tend to have to like forcibly, manually pull the data down and extract it on a day-to-day basis. And that's not very efficient. You can automatically pull a lot of this stuff, and having it automatically into your data warehouse then can have it connected automatically into something like Tableau or whatever analytics you're doing, whether it's in Tableau or Excel or Power BI. Having that whole process automated just smooths out that process, and it allows the analyst to focus less on pulling that data and updating reports and more on doing the actual reports themselves. So kind of what is a data warehouse? It really does a lot of things. Really, some people just use it to answer ad hoc questions. So, maybe your business just wants to know how much, they're saving because of the new program that they put in. And it's a one-time question. They just want to know it now. A person can write a query really easily on the data that exists there. Again, it's kind of getting updated automatically from all these other systems, and without disturbing the rest of the systems. Again, you can build dashboards, kind of some created standardized reports. Also, a lot of like research and costing opportunities, like we talked about earlier. We've done it with health, kind of do it with kind of any industry, but it all kind of starts with having that centralized system that's really easy to access. But it really offers your team a lot of opportunities in the sense of what to do. And I think it's one of those things that sometimes gets missed as the sexier side of data tends to be things like data science or machine learning, whereas there's a lot said about making sure it's correct in place and in a place that's easy to access so you can actually answer these questions. Again, like when I showed those charts earlier, they're not it wasn't necessarily complex, but being able to find those data points quickly could possibly save your company, thousands or hundreds of thousands based on the size of your company, without having to, write a complex model. So that's kind of the benefit of having this centralized data warehouse, is just having a central point where your company can kind of rely on this data. Kind of what I don't want to go too technical, but I did want to kind of talk about like what does data warehouse look like, and kind of why is, for those who maybe are more technical, like why even use one? Can't I just use my database system? Again, I talked about internal transaction systems. That's typically some sort of internal database. So there's a few reasons why people use data warehouses and why it looks like the way it looks like. The reasons people use data warehouses is because generally you can't or you shouldn't be running analytical queries onto your transaction systems that are actually doing transactions live, because that risks, your transactions that are going live that should be happening as fast as you slow down. You've got other people querying it, running analytical queries, which usually take a lot of time. And you don't want that happening. So you generally need a separate system. But also on top of that, data warehouses are really developed for analytics. Those transactions are really developed for what transactions? Again, like they're inserting new rows of a customer buying a product. They're updating customers' address info. They're more of those kind of transactions. Whereas analytical work is you're taking all the customers from store A or trying to pivot customers by stores and group that all together and sum that all together, and you're hitting basically, if you think about it, all the rows in your database. And so that's generally why we don't like to access the database directly, and we use a data warehouse. And then on top of that, we end up changing how the database tends to look. Instead of it being very what we call normalized, which means a lot of stuff can be very far apart, in the sense that tables might be, you might have, in this case, it's very easy, right? Like you've got a central table that's connected to a dim table, but in an actual database, you're going to have table connected to table connected to table on a large daisy chain. And for people who write queries, that can get very obnoxious because you're constantly having to write what we call joins to join all these tables together. And in this case, you've just got a central table, and you know that central table connects to all the tables around it, and it's pretty straightforward. And this just makes it easier for analysts to use, and probably even like non-data user to kind of look at and understand. The central table tends to be, the transactions themselves, and all of the dim tables around it, the descriptions about that transaction. So this fact table might be the transactions from, but one of these dim tables might have the actual store information, so the store name, the store location. Another one might have product information, so it might be the product type, the category, the product name. Whereas this fact table just has the IDs and the amount of and the date or something like that. And so it really is just the bare, like, what does this represent? And that way, it just kind of reduces the amount of redundancy of data, but also makes it super easy to access all that data when you need it. So what are kind of the benefits of having a centralized data source? And I've kind of brought this up, but I'm going to kind of just solidify it now. It's a one-stop shop for data. Depending on how you build it, it's just easy to hopefully access all that data in one foul swoop. You're not stuck, having to pull all this data, pull report A from Salesforce, pull report B from Workday, put them into an Excel, do some weird manipulations, and then get your answers. Instead, now you've got a centralized system that automatically pulls that data, and then if you've got some report or Tableau or Power BI, it's all automatically there, and it's all connected already. Having to, again, extract 4 or 5 places, you've got one place to pull all this data from. It's easy to understand. Again, you don't have to deal with your typical database. You're dealing with what we call a data warehouse, which makes it simpler. Typically, an analyst or someone who maybe has very little understanding of databases themselves can tend to work with it very, very easily and safely. I think that's the other thing, is it's very easy in a complex database to accidentally run a query in the wrong way, where you get the wrong information. Where it tends to be the fact that in a data warehouse, it should be created in such a way that a user can come at it and trust the data and run a query in a way that makes sense pretty easily. And again, it's built for analytics in the sense that how it's designed is really built to run analytical queries. I didn't necessarily go into too much about like the architecture because I don't want to go too much, but like especially with modern data warehouses, as data gets bigger and bigger, things like we call it like Redshift or BigQuery, where there's a lot of things where there's like a lot of parallel processing and things like that that go into it. They're really built for analytics because they're built for running large queries on large sets of data very quickly. But even just the design of how a data warehouse is designed, it's also just geared towards running metrics and numbers and aggregations very quickly rather than being very, very slow and joining across multiple tables. All right, so now how do we actually get your data from your data source to a data warehouse, which I'm just going to put DW for short. So there's a lot of tools these days and a lot of options that your companies can use. Some are free, some are not. Airflow, which is that first one there, is free to use. It does require, though, that you've got someone that's technical, in the sense that Airflow is a Python framework, or it's a library, but it comes across more like a framework. So for anyone who's used it, it's a lot of quote unquote plug and play, in the sense that everything's kind of in its own, like there's a bunch of tasks you can essentially call, and it's very easy to use if you're a Python person, but it's very complicated to use if you're not. So although technically it's free, you'll end up paying for someone's time. because you will need someone that understands how to set it up and manage it and build it and continue to run it as time goes on. Stitch data is a little bit easier in the sense that it is built more drag and droppy. So theoretically, anyone could use it. I still think it requires someone that's somewhat technical, just because you need someone that thinks through the process, not just trying to pull data without really thinking through the implications. It's easier, but because of the fact that it's drag and drop, it's much more limited. Airflow, you can kind of write custom code. Stitch, there's some options to write some more custom stuff, but most of it's very drag and drop, and you can only do what they've kind of got there. You're kind of limited to what they have. Similar thing can be said for AWS Glue. It's built for AWS and also kind of a little less flexible than Airflow. And the other big thing with AWS Glue is it's only for AWS, and so you're going to have issues if you want to migrate to different cloud technology. So that's another kind of problem that you run into. And then Scoop, that's not necessarily an ETL tool, but this has more to do with like Hadoop and HDFS, and I'm not going to go too much into it, but it's just an option out there. Again, you're going to need someone that's a lot more technical to use it, but it's also built so to simplify how much worse it could be. Generally, if I come into a place, I'll use something like Airflow or Luigi, which I didn't put up here, but it's another kind of Python framework. So those are different ways. And what these basically do is they take data, and they help you take that data from point A to point B. They help you pull that data from your data source and put it into data warehouse. They do what we call transforms, and they'll basically take all that data and make it fit a data warehouse. Like I said, a data warehouse has a slightly different structure to a typical database, and so they make it kind of fit into those new tables. So that's kind of the process. This is kind of the processing. This is why we typically call things data pipelines, as these are typically kind of look like pipes. They're piped from one point to another. Okay, but how do we manage all this? And this is something I just kind of wanted to bring in, especially with small and medium businesses. I think one of the concepts that you run into is I don't have, a small or medium business might not have a dedicated system admin. They might not have someone that really they can afford to keep all the time, just to manage their own like databases and servers and systems, because it gets very expensive to have 2 or 3 people just to manage this. If your business is only doing $2 to $5 million a year, and you've got to pay 3 people that all cost upwards of $100,000 to manage these systems. And so how do you end up managing all of this without taking on people? Because it's unavoidable. You'll have to hire either one person or a consultant to set all this up. Is the cloud, which is, it's not just a cliche. It really is a very useful tool. I like to tell people, it gives a lot of small businesses and medium businesses access to $1 million corporations have. Working for large corporations, you see that, they are all using the same cloud technology. They're AWS, they're all using Azure or Google Cloud. So being able to access this stuff actually gives small and medium businesses access to the same stuff that Capital One is using or any other large company. So I think the cloud is a great kind of catch-all for a lot of people, as it can definitely save you money because you don't have to pay as many people to manage stuff, but still have access to a lot of powerful tools. And really, what the cloud does that kind of simplifies everything is one of the main things I think is easy access and security management. Whereas typically there's a lot of work that goes into setting up networks and setting up security and setting up who can access what. The cloud really does make a lot of that simpler, as a lot of that can be done in the console, which is just like AWS's kind of GUI, or like basically website page. So it's really easy to do. You should still have essentially someone set it up that knows and understands the cloud, but it definitely is not as complex as having someone having to set up a server, plug in Ethernet cables, set up firewalls that are actually physical at your company. And in this case, instead of doing that, you just go set it up virtually um, on AWS, on Azure, or something like that. And so that makes it much easier to manage all of this. And it automatically does things like logging and tracking, things like that you want to do that would require a lot of setup on your side. And that also brings in system administration. So a lot of the problems that you run into when you have things like servers um, or other things on site is when things go down, you need your system admin to fix it. But for a lot of things, either set up or AWS and things like that have it set up automatically, or you can kind of either pay for a little extra where AWS will automatically take care of, oh, your server went down. They'll run through their own checklist of things to kind of try to fix it, rather than having to have a person there that needs to fix it. Because servers go down all the time. They eventually get old. They eventually become, need to be replaced. But now that you don't have to think about it, you can just let a company like AWS deal with it, and they'll make sure that your server's constantly going, and you won't have to think about, is my server going to die in 2 years? Is it going to, do I have a backup plan? Things like that. And then scaling without buying new hardware. And I think this is the biggest thing, especially working at large companies, that you learn that is very helpful. If you've ever worked for a large company that still uses servers that are on site, you quickly find out that it's very painful to add to need a new thing, to need any new thing. If you have for suddenly a petabyte of data, you can't just get it. You'll often have to go through some sort of procurement process because you might not have the right amount of servers. So you need to buy new servers, and that could take months between having to go through contracts and get them built and get them plugged in. And with AWS or GCP or Azure, a lot of these cloud providers, let you do it in a few clicks. Suddenly you have exactly what you need. I need another petabyte of data, which I don't think most or small and medium businesses need, but if you needed it, it's there. So having that easy access to scale, I think, is an advantage. So yeah, these are the reasons why I'll usually push people towards cloud. Some people still run things on premise, and I understand that. Sometimes it's for security reasons, especially with healthcare. But especially if you're a small or medium business, it's a way you can gain huge advantages without the huge cost of hiring a bunch of developers to manage it on premise. All right, now I just wanted to talk quickly about data visualization tools before I kind of just go through just a quick demo and walking through Tableau and kind of some things you can do with it, and pretty much anyone can do with it. So there's a lot of options for data visualization tools. I think the biggest thing is, don't let the pretty bells and whistles fool you. At the end of the day, you generally don't need a complex data visualization tool. You generally need something that will tell you three to five KPIs, key performance indicators, and then some ability to drill down into that information. And so that's generally what you need. And so I think Tableau, Looker, Power BI are all pretty comparable in those. For most people, for what most people need, they're pretty comparable. If you've got more complex needs, then you should obviously analyze the different products. But for most reporting, I think you could safely choose any of them and be okay with them. It really depends on your external needs as well. But I think for most of it, it comes down to cost. I think Power BI is somewhere like $8.99 a month per user, whereas Tableau is somewhere in the range of $80 a month per user. And then I actually don't have Looker off the top of my head. But so I think for the most part, it depends on what you're willing to pay and what functionality you need, because they basically all have the same functionality as far as similar charts, similar abilities to filter. It's more about what you need in the end. Also, if you want to do things like share these charts live on maybe your internal website that you've set up, pretty much all of them can do that. They've got some sort of server set up that you can share them. They'll generally be more expensive, but they all kind of do the same thing. They all let you report the same data pretty quickly live and connect to a wide variety of data sources. And I'll kind of go into that now. Let's see if I can find this one. So I just want to kind of go over quickly what you could do with Tableau. So, okay. For those who are out there, this is public data before someone thinks I'm sharing healthcare data that's private. I'm actually going to show you how to do this. So you can do this too. BigQuery. So one, I want to show that I'm connecting to Google BigQuery. So you basically, this one is the only thing you're gonna have to set up, which is essentially a GCP account. But once you have it set up, you can essentially authenticate Tableau through that. And then it's going to essentially try to connect to Google BigQuery. And so now you're directly connected to basically Google's API. And this is something anyone can do in the sense these data sets that I'm going to show you are public. Let me see. Make sure this is right. This might not be right, so I'm going to apologize. Big query. Okay, hold on. I clearly can't remember. Oh. All right. So like I said, these are public data sets. Like I actually have the only thing I had to write was add in this project, which is BigQuery-public data. And you've got a ton of public data that you can use that pretty much anyone can access. So if you want to mess around with doing some sort of analytics, you can do it. Like this data exists. It might cost a little eventually. Like I think Google Cloud gives you pretty much free data for a little bit, but you can at a certain point pretty much just access this data directly. So I'm gonna look for CMS. So CMS, this is like the healthcare data. Let's do CMS Medicare. And so these are the different data sets that it has in it, the different tables. So you can essentially pull all this information. So maybe I'm interested in inpatient charges from 2014. And so now you'll see that I'm pulling this table. And what is also kind of nice with Tableau is you can start doing what you typically would do, joining. I talked about joining earlier, in Tableau automatically. So for instance, I know that hospital general info connects to inpatient charges by provider ID. So this automatically joins these two data sets together for me. And I didn't have to write a query. So for people who aren't understanding or don't really know what queries are, this is great. Then I'll turn this on extract because if it's on live, it's going to try running the data every few seconds. So I'm just going to update this now. It's going to take a little bit. I'm going to start kind of building off this data just to kind of show you, now that we've got access to this data, again, we've got access to all this data. This is a free data set anyone can use. It's not at the patient level. This is at the provider level, so it's at the hospital level. So I'll kind of show you what it gives you. It's going to run an extract really quick. Hold on. So yeah, so basically what we've essentially done is gained access to Google's API for BigQuery, set up a project. I mean, I've got a project on GCP, which is the only thing you're essentially going to have to do is with your Google account, set up the ability to run Google Cloud. And after that, you've got access to their data, kind of given to everyone to use as they want. Going to be running a little bit. We'll kind of go over the different things with Tableau. Does anyone have any, like, I don't know if you can actually run, let's see, if there's any Q&A. If you have any questions, I think you might be able to post them. If not, I'll just kind of keep going, but. All right, so technically now you've got, again, all that data pulled out, and you've got something that for some people might feel a little Excel-y. Again, this is very drag and droppy in the sense that anyone can kind of, or you can kind of just pull this data over here and drop it where you want. So for instance, in this case, maybe you're interested in provider state, and the total discharges per state. It's very, very easy to kind of see those kind of numbers. One of the things I wanted to kind of show was, let's see, I want to show, let's do bins. So I showed earlier that kind of histogram chart. And so one thing you can do to kind of build a histogram with Tableau is you can do something called bins. And what this will essentially do is allow you to bucket things into specific numbers. In this case, we're doing average total payments. Oh, sorry, not average total. No, yeah, that's right. Average total payments. And we're going to put them into basically bins. Basically, that's how far apart each average cost is from each other. So I'll show you what this kind of looks like. So I'm going to put 2,500 just because it makes sense to me. So now if we kind of flesh this out and look at it, it's kind of grouped things together, right? It's kind of showing things in. Essentially, let's see if I can fix that. I don't think it's going to change for now. Basically, these are how we want to count, like how many people are in different groupings for costs, like how many different specific providers are in each of these cost buckets. So we can put these number of records, or in this case, it's like the specific DRG code, which I'm going to show. So basically, what my goal is from here is to kind of show specific procedures that maybe cost more than they should. So for example, DRG definition, it's not the exact procedure code. It's something similar. So this will basically let us pick specific groupings of procedures. I only want to look at some. Let's see, I want to look at. So I want to only look at hernias, just to kind of see like, well, what's the grouping of average cost for a hernia? So if we look at this, so we can end up switching this here really quickly. A histogram kind of chart. You can kind of see that, like I said earlier, there's kind of a central cost, right? Like at the end of the day, average is average for most. And then there's kind of these weird things that are like, wait, why is the average somewhere around 12 to 10K? And the top is somewhere 30K. Now, one reason this is because if I were to pull in this drug definition, and one thing you can do is actually set colors to like be different definitions. So I'll show you what I mean. So basically now we've set up a legend so that you can see, okay, what is the average cost for all these various things? Or like how many providers fit into each of these buckets for what specific procedure. So for example, here we see that there's kind of a clear pattern here, is many of the providers for specifically hernia procedures except inlingual and femoral kind of fit. These seem to be a lower cost procedure in general, right? Like these kind of have their own distribution here. Similarly, then again, you've got drug definition 354. It kind of fits into its own kind of distribution here, where it's like it kind of fits. It's got low to begin. It's got these two middles and this end. And the weird ones that seem to be more expensive specifically seem to be 353. But I'm going to point out one thing is there does seem to be one provider that seems to be way off. That seems to be, for some reason, unlike everyone else who's charging 10, 12, 15K for this procedure or this specific procedure. There's one that's weird and off here, and I would be curious into that. And with Tableau, one of the nice things is you can actually go through and look and say, oh, I want to know more information about that specific thing. Again, right here, it's very high level, but you can actually go in, scroll in, pull data, and we can look in and see, oh, here's their address, have that information here, but you can actually look and see a lot of information about that specific healthcare provider. So that's kind of, I think, one of the advantages with Tableau is like it's very easy to drill into information. Again, this kind of, I think, again, kind of tells you that story. Like if I were to even filter this further, let's show filter. And we can kind of show the filter like I just did. I only want to see, let's see, 353. So we're really only interested in, I think it's 354. So now we can kind of see that there's this big gap. And now what's kind of a bummer is you don't see all the middle sections here. So it almost seems like this is not that big of a deal, but this is actually should be somewhere over here. But again, you still have this very kind of consistent pattern where very much in the center, things seem to make sense. And then these three bins might be a little bit suspect. Again, very quick, very easy to see, and you can drill into that information very quickly. And then for those of you who maybe are a little more interested in doing things that are on a map or doing some sort of graphics that way, Tableau allows you to do that very quickly. All you generally need is things like zip code or city, or even so zip code or city. So for instance, if I put in zip code, and then we just want to figure out the total discharges, let's say total discharges, we can actually go to the map. And now we kind of can see the circle size. Basically, they're basing this off of the total discharges. And this might not be necessarily as interesting information, but definitely lets you look at that and kind of see where things are at. And then you can come from here. Maybe you want to filter by state. Just look at something like Georgia. Oops. So we can kind of look just at Georgia, see where the kind of clusters of most discharges are. Again, I'm sure that if you were to look even further in here, let's see if I can find city, if I can just label things. Let me do that. Okay, so now I can kind of see what cities are kind of around in these different areas. They've also kind of grouped it even further by the city, but you can see where those cities are. And so that's kind of Tableau for people. Again, this isn't meant to be like super in depth. It's really just it's just kind of built to be more of a high level conversation about what you can do really quickly. From here you can build out whole dashboards. This is just Google. These are basically just what we call sheets. From here you can actually build things called dashboards. But I kind of just want to show you how kind of quick and easy it is to use. Like it really is just very drag and droppy. Anyone, if they've got questions that they need to answer very quickly, can kind of use this to quickly poke around and access data and look into it and drill into it. Again, if you want to drill into this data, all it takes is a click. And suddenly you can see all of these different providers and what specific procedure they were doing with the click of a button. And then you can even export this data. So if you need to like export a report, because generally, again, like if I look at this and I see this 30K, the action I need to take is actually I need to either send them a letter or call them, or figure out how we can fix it. And so now we've got that information, we can get to it. And so, yeah, that's kind of what I wanted to cover with Tableau. Just something quick to show you again how easy it is, kind of drag and drop, move around, drill down into information. If you need to write calculated fields, that's also a thing. So for people who are very Excel familiar, basically you can do the same thing as you would in Excel, writing a lot of formulas. So thank you, I think, for listening so far. I don't know if you guys have access to the Q&A if you have any questions. Again, like the purpose of this talk was kind of cover just the broad swaths of technologies that you could use and why you should use it for small and medium businesses. So if helpful, I'm hoping this was helpful. Let me know if you need anything as far as Q&A goes. But I've pretty much done everything I want to talk about. So let me know. All right, maybe I didn't enable Q&A. I'm not sure. But hmm, well, if anyone has any questions, or if I can't seem to should allow questions. So if no one has any questions, I'm going to end the webinar. Thank you for joining me on this talk. I'm going to try to do a few more where I'm just covering this subject kind of again and kind of working through it a little more on the strategy side. And I'm also going to be doing one where I'm going to be walking through writing a pipeline in Airflow, just to kind of show people how to write things in Airflow and how you can use it to pull data out from different sources online. So thank you so much, and I hope to see you guys again soon.